Good afternoon, everyone. So I think we'll start now this new webinar session on cryptographic inventory. We had the session on cryptographic inventory last year. It was a real success, and since it's still a very hot topic, things are moving on this field. It felt important to us to have a new session on this topic. If you have any questions, if you want to react, please do it in the chat. We'll try to grab the questions, most probably at the end of the webinar. And if we don't have time to answer the questions, we'll do it afterwards when we'll send the recording. So this webinar is being recorded, and you should receive the video probably sometimes next week after a quick video cleaning. So let's begin. So I am Nicolas Drouot, in charge of marketing and communication for Cryptographic Security. And today I am with Martin Zuber, without his hiker outfit, but here flesh and bones.
Thanks, Nicolas. Yeah. So I'm a cryptography engineer, as it says, and I work in the R&D team. Among the things I do is work on our inventory product, and so this is what I'll be talking about today.
Thank you, Martin. So we wanted to start with a question. So do you know which cryptographic algorithm are running on your infrastructure right now? So that's the question every CISO should be asking, and the answer most of the time is that most of organizations don't know the answers. So it's normal because cryptography has not been an asset that was monitored so far, because it was proven reliable, but things are changing, and it's the subject of today's webinar. So 4 parts for this webinar today. So why should we start cryptographic inventory now, which means today? Then Martin will focus on 3 myths on cryptographic inventory. He will debunk, actually. Third part, where to start. If I want to run a cryptographic inventory, where should I start? And you will get few takeaways at the end of the webinar and a few insights. So first part. Cryptography is the root of trust. So some of you who have been following us over the past webinars, you may have seen this building which was representing the organization, which was relying on one pillar, which was representing cryptography. So cryptography is really the root of everything, the root of trust, and it's not just another security layer. Actually, all these security layers that are currently displayed on this slide, such as HTTPS, VPN, signatures, certificates, SSH, and so on and so forth, they are all using cryptography. So if cryptography fails, then the whole building collapses, and the trust is not there anymore, which means actually, we gave a few examples of what could happen, such as digital signatures. They don't mean anything anymore. Anyone can use your identity to do some actions, to corrupt some data or whatever. Your sensitive data could become exposed and could be read by anyone. And the impact is massive costs in terms of trying to fix this issue, and the damages on the reputation are huge, and the survival of the company could be questioned. It all began with the quantum threat. So far, the classical cryptography, classical asymmetric cryptography, such as RSA 2048, was considered reliable because it would take thousands of years with a classical computer to break this cryptography. So much more than a human life. So we can see that we can say that actually it's you can trust this, and it can't be broken, which is not true anymore. Which won't be true anymore in the coming years, because quantum computers to come should be able to break this cryptography at the beginning, not in a few minutes, but in a few days. Then when technology will improve, it's going to be a few hours, then in the end, a few minutes, using the Shor algorithm. So it's a real change, and the impact is that the security is collapsing. It's not a reduction of cybersecurity, or reduction security disappears completely, and the impact is huge on the company. Regulation actually is the regulations are showing this acceleration of deadlines. We all know the deadline of 2035 that was given by the NIST. I think it was 2 years ago, when they published the first post-quantum cryptographic algorithm. This date, 2035, is supposed to be the date from which the classical asymmetric cryptography won't be allowed anymore. But then federal agencies in the US have been requesting the White House has been requesting, that the federal agencies started the inventory from 2022 with milestones to assess their progress every year. And then the other countries have been publishing some deadlines, such as Australia. They recommend to have fully migrated their infrastructures to consume-safe cryptography by 2030. Europe and UK, Canada, and so on have been accelerating their calendar, and the message that is commonly shared is that you should start as soon as possible, starting with a cryptographic inventory, because you have to be quantum resistant by 2030, 2035. Well, the sooner the better. So, Martin, do you want to share with us what is a cryptographic inventory?
I do, thanks. I do, and let me give you, I think, what for us here at CryptoNext is a clear definition. And I'm going to say crypto maybe sometimes. It doesn't mean crypto money, it means cryptographic or cryptography. A crypto inventory is a continuous process, and we want to stress the word continuous here, by which an organization identifies, collects, and centralizes all of its cryptographic assets. And that means answering a bunch of questions, like which algorithms are being used, on which servers, inside which applications, which certificates, keys, any and all of these. And concretely, what does this cover? Well, the slide here shows 4 main areas. And the first is hardware. That's your HSMs, your TPMs, your network equipment. And these are physical devices that hold keys and perform cryptographic operations. And they're often the most forgotten in this process. The second is applications, and that's source code, compiled binaries, third-party libraries. And so the cryptography here is embedded deep in the software stack, and sometimes in ways that nobody really documented. The third one is infrastructure. That means cloud environments, your servers, the protocols. And think about what TLS version your load balancer is actually using right now, and you'll find out that you actually might not know. And the fourth one is network traffic, observing live flows, TLS and SSH handshakes. And this is where there's a difference, maybe, between the systems that the way systems actually communicate and the way that they are configured. And so they might not actually negotiate what they're configured to support. The key insight here is that no single source gives you the full picture, and you need to combine all four to get an idea. Now I'm going to get on to three myths, because when you talk to CISOs and security teams about starting a cryptographic inventory, we hear the same objections most of the time, and we want to walk you through the most common ones. The first one, we have time. Well, let's look at the numbers here. And a full cryptographic inventory for a mid to large organization typically takes 2 to 3 years. Right? That's not a guess. That's what organizations that did it actually report. Now, if we compare that to the deadlines, Canada and the UK have both set 2028 as the target date for having a cryptographic inventory in place. Well, that's less than like 2 years from now. And if you haven't started, you're already late. So that's too bad. And then there's also one last thing, which is something you've probably heard of. It's a threat that's called harvest now, decrypt later. And the point of that, very quickly, is that state-level adversaries are already intercepting and storing encrypted communications today. And they're betting that they'll be able to decrypt them once quantum computers become available, practical quantum computers. Now, if the data you're protecting now needs to stay confidential for like 10, 15, 20 years, that's the case in healthcare, defense, finance, government, then the threat is actually not theoretical. It is happening right now. So no, you don't actually have time. The second myth is that it's a one-time effort. We'll do it once, we'll check the box, and we move on. This actually misses the point. A cryptographic inventory is not a one-shot audit. It's a continuous capability that delivers value at every stage of your journey. And, well, to start your journey today, before you even think about post-quantum integration and migration, an inventory helps you uncover weak or deprecated classical cryptography. And we're talking about like SHA-1, which is a hash function being used somewhere, or like some RSA key, which is too short, a TLS configuration that's outdated. And these are real security problems that you can fix right now without waiting for PQC, and which are completely independent from PQC. Now, during the PQC migration, because that's going to become necessary, it's going to take a few years for most organizations, right? An inventory then becomes your tracking dashboard. And it tells you how far along you are and which systems have been migrated and which ones still need attention. And without it, you're basically just flying blind in this big, long migration process. And that after the migration, you actually still need it, right? Compliance doesn't stop. The new applications that you want to deploy get deployed, may have vulnerabilities, new libraries get pulled in, and cryptography actually drifts. That's the way that it's always been. And so there's going to be changes there as well, parameter sets, even algorithms maybe. So it's not a checkbox, it's an infrastructure that you build for today and for the future. And the third myth is I'm waiting for the PQC market to mature. Now, this one is based on a misunderstanding, because inventory and PQC migration are two completely separate activities, actually. A cryptographic inventory is algorithm agnostic. It doesn't really care whether you're using RSA, elliptic curves, MLChem, and just observes what's actually deployed. And you can and should start your inventory today without having made any decision about your target PQC stack. The two phases are fully independent, right? And if you think of it this way, you need a map before you can plan a route, right? The inventory is the map, and the migration is the route. Now, by the way, the premise of this objection is also wrong, because the PQC market is mature. NIST finalized its three first post-quantum standards in 2024. Industrial solutions are available. For instance, here at CryptoNext also, that's another product, but not just. And every major regulatory body is recommending organizations act now for the migration. This is what agencies call a no-regret move, right? Regardless of how the quantum timeline plays out, doing an inventory makes you more secure today and more prepared for tomorrow, right? There's no scenario where you regret having done it.
So where to start? That's the third part of this session. Where to start? We have been building this DISCO framework. We had fun building giving the name to this, but actually we wanted to represent the steps to do this inventory. The first one would be to discover what you already have actually in store, let's say. So you have already sources to get information on cryptography, such as spreadsheets, SBOMs, EDRs, logs, and so on and so forth. List the source and gather the information because you're going to use it. The second step would be to be more active into discovering this cryptography using dedicated sensors such as HSM scanners, binary scanners, database, and so on and so forth, and network probes, of course, to catch the cryptography that is used in your network. And this data you got from these two first steps, you're going to store it into a database, a centralized database, because you want to unify this data. And it's not about only storing it, but correlating this data, because you want to actually correlating this data will break silos and will bring additional information that will show the dependencies between an asset and the cryptography. So how the asset is actually, or the data is interacting with other assets using cryptography. And it's a way to analyze what you actually have been using and to monitor it continuously. And the last step would be to be able to measure automatically and produce audit-ready evidence to show compliance. And actually, it's not a one-way journey, like Martin has been mentioning previously. Actually, it's going to be a loop, a virtuous loop, because you are going to uncover cryptography, to store, to analyze, and do it a bit deeper every time. And you're going to deploy new systems. You're going to deploy new cryptography, such as post-quantum cryptography or any other type of quantum-resistant cryptography. And you will need to monitor this progression to quantum-resistant cryptography. So this is going to be a loop you will want to do continuously. So if you want to start this week, let's say you could do something actually without like launching a huge project so far. The first thing you could do would actually run data sensitivity assessment. So trying to identify your most sensitive data that you need to prioritize for the protection. So if you want to migrate some cryptography to quantum-resistant cryptography, what should you do first would be to protect first the most sensitive data for your company. So you need to run this assessment and to build this list, and you can do it right now actually. The second thing you could do this week, we already mentioned it, was the first step of the framework we have been presenting, is to audit what you already have as cryptographic sources. And the third one would be you could or should run POCs, tests, to try to inventory cryptography on a targeted scope, on a reduced perimeter. It will help you to understand what you can uncover because cryptography is not just about algorithms, but you will have algorithms, protocols, keys, certificates. Many cryptography is embedding many components actually, and a POC will help you understand how difficult it is, will help you understand how difficult it is to uncover, to deploy, to analyze, will help you to gather some insights to help you convince your direction, your board, to run it in a larger scale. So all the organizations we have been talking to are going this way because it's the best way to start a project. And like Martin has been mentioning, it's a no regret move because it will make you smarter and better understand what's going on in your organization's infrastructures. So key takeaways to finish these presentations. The first one, inventory is urgent, not in 5 years. It's going to be now. Why is that? Because we've been speaking to large banks in the US, and one of them, they mentioned that it took them 3 years to complete cryptographic inventory. 3 years. So if you start today in 2026, it will bring you to 2029 to have just a complete mapping of your cryptography, which is a bit late considering that some deadlines are already passed. Means that you may have read this announcement by Google 2 weeks ago. And they mentioned that they foresee quantum computer powerful enough ready by 2029. So actually it's an announcement by Google. So maybe they are using it to promote something. But actually, even if they are wrong by 1 or 2 years, still it's coming quickly. So the sooner you start inventorying it, the better. And actually, 2 weeks ago, we had a big trade show in cybersecurity, and we've been talking to a lot of organizations, and a lot of them were thinking to prepare some project to launch inventory project to launch in 2027, so next year. So to negotiate a budget with their board this year to launch the project next year. So it's going to be a bit late. So the sooner you do this job, the better, and the sooner you'll be able to understand what you need to migrate to quantum-resistant cryptography in the short term. Second takeaway, Martin has been going through it. It's a continuous process, so it's not a one-time journey. You will start inventorying your cryptography today. It will bring you some insights you can use today. It's going to be something you will have to do continuously because you will need to uncover weak cryptography like continuously. You will need to understand the new systems you've been deploying, what type of cryptography they are using, is it compliant or not. So it's something you won't regret, whatever you're doing. So it's a no regret move. And the third insight, you can start now because the tools exist. Actually, at CryptoNext, we have an inventorying tool, and we plan to actually propose a webinar session sometime in June to demonstrate this tool, inventorying tool, to show you the insights you can get from this tool. So you can stay tuned and wait for this session to come. So yeah, you can start now. The tools are here, and actually we showed you some steps you can already deploy right now. Few words on CryptoNext before finishing this presentation. So for those who don't know already, we come from the research in PQC. Our founder was a researcher in post-quantum cryptography. And so we are proposing solutions to help organizations successfully transition to post-quantum cryptography with the three main phases we have been identifying, which was the preparation phase with inventory, the protection where they can deploy our quantum-safe library to protect their assets. And the third phase is to do it in a crypto-agile way. So they don't want to deploy they don't want to deploy post-quantum cryptography like just replace the traditional cryptography with PQC. But because if an algorithm proves to be vulnerable, or if it's becoming, if the regulation is changing, they don't want to go through like many years project to be able to replace it in the code of the applications, in the infrastructures and so on. They want to be able, in an agile way, to change the algorithm. And we have a solutions for this usage. And actually, we have been presenting a webinar a few weeks ago. So questions and answers. I don't know. Do we have any questions,
yes,
Martin?
We've got 3 questions, which is nice. We'll try and go through them quickly, I think, because we don't have much time. But, well, thank you for being here all through this. And if you still have questions while I talk, I think you can still ask them, if I'm not wrong. The first question, and I'm going to read them out because you can't see the other people's questions, I think, is, hi, thank you for the insights. Well, you're welcome. And at what point does PQC become insufficient, where the only real solution is actual quantum key distribution or quantum network infrastructure rather than classical algorithms designed to resist quantum attacks? Are there specific use cases where you are already recommending QKD or quantum cryptography rather than PQC? Short answer is no, we're not recommending QKD. And neither are any security agencies, although it is a very interesting and a promising technology. QKD right now doesn't have the maturity of PQC, and even when it gets to that maturity, it will have great limitations in terms of where it can be deployed or even the costs for deployment, right? So we're actually working with a lot of QKD people because we do believe what ANSI and other security agencies say, which is that hybridization between PQC and QKD, even wherever QKD is being deployed, is a really good thing to have for security. But QKD on its own will never be able to cover all of the needs of the market and just the reality of how communication today works. So yeah, that's our answer here at CryptoNext. And there were 2 other questions. One, if all certificates are managed by a CLM, will that reduce the time needed to complete the cryptographic inventory? 2 to 3 years feels very significant. That's very legitimate. And the short answer is yes, the CLM helps a lot, but less actually than one might think. And that's precisely why our tools are designed to work together. A CLM gives you valuable visibility over X5 and 9 certificates that you're using and storing and handling with the CLM. So that's all of the signature algorithms, key sizes, expiration dates. And this is a genuine building block for the inventory. A lot of information is there, and you can clearly start with that advantage. And in fact, that's exactly why our inventory tool that I helped develop, it's called Compass, it integrates natively with the CLMs on the market. And the idea is to automatically retrieve all of that information that the CLM holds and then centralize it with the inventory. And then, because we have data from other sources, code scanners, network probes, HSM scanners, then we can use that information better than if we just had the CLM information. Because in fact, certificates only represent a fraction of what cryptographic inventory covers. And so the CLM doesn't really see everything else, the symmetric algorithms used in the applications, hash functions, at rest encryption of databases. Anyway, there's a bunch, so many applications of crypto. And there's one subtle point about CLMs also. It's the fact that the CLMs manage the certificates that are enrolled in it, right? And they do it really well, but they don't see self-signed certificates. They float outside the official process. And they don't see forgotten certificates, sitting on legacy systems, for instance. And that's the whole point of an inventory. It reveals by cross-referencing CLM data with other data what's missing from the CLM, which you couldn't just get from the CLM by definition. And then there's a last question here. Hello, while all vulnerable cryptographic assets should be considered and remediated, shouldn't discovery be prioritized based on organizational risk? And this would imply a risk-based approach tied to critical assets rather than a global discovery process covering the entire technical infrastructure. Yes, that's a very good question, and it does touch on a real methodological debate within the community. And the short answer is yes. Again, absolutely, and that's what every agency recommends. But we need to distinguish between prioritization and scope. Risk-based prioritization is essential, and I think we talked about it in the slides. We talked about starting with the data sensitivity assessment, identifying your most sensitive data and the systems that handle it. And that's the approach that you're describing. You start from critical business assets and you identify the systems that handle them, and then you focus your discovery efforts on those where risk is the highest. But, and this is where we need to add some nuance, an exclusively risk-based approach has two significant blind spots, usually is what we have as an answer for this. Is the first one is you can only assess cryptographic risks on what you already have identified. So it's sort of same as the CLM answer in that way. And an inventory comes when an inventory comes in, it surfaces assets that nobody had mapped. And that's where also your risk assessment will not have worked for those assets. And the second is the interconnection problem, which is that a non-critical system can serve as a pivot toward the critical one, which is always a bit of a problem, in computer science and infrastructure. It's all sort of mixed together. And so in practice, a hybrid approach might be recommended. Obviously, you don't want to go all in risk-based prioritization, for the order and intensity of remediation, yes. But the broadest possible discovery, even a shallow one, to make sure that you're not building your strategy on an incomplete map, right? Build a big map, even sort of not very detailed first, so that you can actually focus then your efforts on the places that you see have actual highest risk. Right, that's a lot of answers, a lot of questions and long answers. So I think that'll have to be it for today. Right. Yeah, I think we're reaching the end of this session and we are running out of time actually. And so we'll need to close this session. But thank you for having followed this session until the end. And we wish you a very good day, and we'll send you the recording in the coming days and keep you in front of the next session. Thank you. Bye.